Hello. In my last video, we talked about a Java concurrency example. Try to load the arc with multithreading. We added a main method. We also created a helper thread trying to speed up the process. Let's continue with what we left last time. Okay, let's copy the code and paste it into Eclipse. So it's from here. Let's copy it to the Eclipse and fix the boiling plate code. Okay. Run this program. Last time we saw the main thread loaded 19 pairs and the helper thread loaded 8 pairs. There is a problem about this. You see the print. The main thread already finished the work before the helper thread even started. See the main thread? It's finished its work. Prepare the candidates and loaded the arc. Then at this point the helper thread is created and then start to do those work. They are not run in parallel and it didn't save time. Let me prove this by put a debugger here. Okay. Put it here and put it here. This is where they start working on the loading. Okay, let's put a debugger and run the debugger. At this point, we see the stack. Only main thread exists. There's no helper thread around. Now the main thread start working. So it start to prepare the candidates. While main thread is busy, there are other cores available to take work. However, there is no other thread around to occupy those available CPU cores. There's only one core is occupied, which is by the main thread. So let's have the main thread finish the looping and print. And now it's the main thread start to create a helper thread and get it started. At this point, the main thread is about to exit. The helper thread now get a chance to do the work. So it can start to prepare candidates and later load the arc. But you see, at this point, the main thread is already ready to exit. They are not running in parallel. Main thread finished the work, then the helper thread start to work. This is not good. Okay, let's get the program run to the finish and print out. Okay, now both threads finished. We can fix this easily by have the helper thread start earlier, so it can start herping as early as possible. Let's put it here, just after the arc is created. Now let's do the same thing. We put a breakpoint here, breakpoint here. This is where the helper thread start working. This is where the main thread start working. Let's run the debugger. Okay. Make this smaller. Okay. At this point, there's only one thread, which is the main thread. Let's step over. Now, the main thread, before it starts working on loading the arc, the first thing is it create a helper and get it started. Now its situation is different. The main thread is about to start working on loading the arc. At the same time, we have a helper thread around, also ready to load the arc. So, different than last time. The main thread can run in core 1. The helper thread can run in core 2 in parallel. So it's more efficient. we let the helper thread load for a while at the same time. The main thread can also load the arc. So we have two threads running on different cores, and they both trying to load the arc, and they work in parallel. Even though you have just one core, it may also be efficient because where one thread is waiting on the I/O, the other thread could proceed. And now let's get the main thread run to finish. Okay, now let's get the helper thread also run to finish. And let's get that program finish. Okay, so you see this time the two program is run in parallel. The main thread and the helper thread, even their printout, start to interleaving. And this is first issue we address. By reordering the code a little bit, we make the helper thread and the main thread run in parallel. We also use a debugger to show the difference. Previously, the main thread finished the work, then the helper thread can start. Now we have the helper thread start first before the main thread start working. And as a result, the helper thread is running one CPU core. The main thread run on another CPU core. They run in parallel and more efficient. And in the next video, we will address another issue. Here, loaded animals is used by load and has animal. And those two methods is not synchronized, not guarded by synchronized keyword. So a possible situation is when you are trying to iterate through the loaded animal, another thread could add a new pair, and you will see concurrent modification exception. We will use a debugger to reveal that bug and show how to fix it.